Hello students, welcome back to the fifth video of this playlist. So in this video, we will be solving the fifth question of the latest paper of Mechanics 1, that is October 2024 paper. So let's see what's the question number 5 from this paper is about. Question number 5, you can see on the screen. So basically the concepts behind question number 5, it's from connected particles and something related to pulleys that has been discussed. These concepts are discussed in chapter number 4, that is dynamics of a particle moving in a straight line. So in order to be able to solve this question, definitely you should have practiced sufficient questions from chapter number 4 of your Mechanics 1 textbook. So let's get started with question number 5. Okay, so here you can see right at the beginning a figure 3 is given, particle P, particle Q, these are hanged over a pulley. So two particles P and Q have masses 3 kg and 5 kg respectively. The particles are connected by a light inextensible string. Light inextensible string means what? It's light, it's not that heavy. That means mass is negligible, which passes over a small smooth fixed pulley. Small smooth means what? It's not rough, it has no irregular surfaces. That means it has no friction. These are basically modeling assumptions as per we learned from chapter 1. Okay, the particles are released from rest with the string taut. The string is tightened. Okay, the and the hanging parts of the string vertical as shown in figure 3. The string is vertical. Okay, immediately after the particles are released from rest, P moves upward with acceleration a meter per second squared, and the tension in the string is T newtons. Okay, the tension in the string is what? T newtons. Okay, most importantly here, most of the students feel difficult to figure out the direction of the tension. It's not that difficult. Have a look on it. Tension is basically always the pulling force. Okay, tension means what? Pulling force. Whenever you see tension, that means it's basically pulling force. So whenever there is tension, the two particles will be pulling each other. That means the pulley will pull the particle P in the upward direction, and the particle P will pull the pulley in the downward direction. This is the direction of tension for P and the pulley. Same goes for Q, upward for Q and downward for the pulley. This is the direction for tension. Fine. So that's how you can keep in mind like how to consider the direction of tension. Fine. Okay, so part A is asking here to write down an equation of motion for what? P. So for particle P we need to write an equation for its motion. Okay, so in which direction particle P is moving? It's moving upward, right? Okay, so for particle P, what are the forces acting? What are the forces acting on the particle P? If you consider this is particle P, the tension force acts upward, right? Its weight is acting downward, right? What's the weight of particle P? This is 3 g Newton, isn't it? 3 g Newton. T Newton acts upward. Its acceleration is what? In the upward direction. So an equation for particle motion of particle P would be what? Take upward. We are taking upward positive. So that would be a tension T minus 3g equals to 3a. Fine. This is the equation for the motion of particle P, and that's what part A has asked for. Okay, next is part B. So part B is asking to find the value of T. Okay, we need to find out the tension of this pulley system, the tension in the system. Okay, so for finding the tension, already in part A we have got an equation for the motion of particle P. So as that, we will derive another equation for what? For the particle Q. Okay, so for Q only, taking downward. For P we took upward as positive. To keep the relationship with that, we will take for particle Q downward as positive. Okay, so for particle Q, what are the forces acting on particle Q? Tension force is pulling it upward, right? Not pushing. Remember, tension is always pulling force. Okay, and in the downward direction, what is acting? Its weight. Weight is 5 g Newton. Okay, its weight is what? 5 g Newton. Okay, acceleration is also downward. Okay, so for particle Q, we can write what? Downward is 5g minus t. This is equals to 5a. Okay, so from this equation, we can make a the subject because we need to find out t. So we need to eliminate a. So let's make a the subject. So you'll get 5g minus capital T over 5. Okay, and previously we got what? In part A we got an equation for particle P. So from there also make A the subject. So if you make A the subject, what you will get? T minus 3g over 3. T minus 3g. T minus 3g over 3. We got two equations for acceleration, right? A. So these are both equal because the string is light inextensible and it is what? Connecting both the particles P and Q. So 5g minus t over 5 equals to what? T minus 3g over what? 3. Now cross multiply. If you do cross multiplication, you will get 15g minus 3t equals to 5t minus what? 15g. Fine. Okay, so take 3t to the right side, so you'll get what? 8t. So 8t equals to 15g plus 15g. Okay, 15g minus 3t, 15g plus 15g, this is what? 30g. That's fine. Okay, so the value for t is 30g over 8, which is what? 15 over 4g Newton, which is basically up to three significant figures. 15 over 4 times 9.8, this is basically 36.75. So we can write 36.8 Newton. Okay, two significant figure will also do, no problem, because as per the standard of the question, it's mentioned at the beginning of the in the front page of this question, of all of the questions, that you can write two significant figures or three significant figures if nothing is mentioned in the question. So we got the value for t up to three significant figures, which is 36.8. That's it. Okay, next is part C. Part C is asking here, okay, it's saying that the total force acting on the pulley due to the string has magnitude F newtons. Okay, so C is asking to find the value of F. We need to find out the magnitude of the force acting on the pulley. So if you consider the pulley, okay, if you see the pulley, like on the pulley, what are the forces acting? One of the tension is acting on the pulley due to the string connecting particle P. This is the tension from particle P. Another tension for particle Q. So that means what? The force acting on particle on the pulley is basically twice of what? T. Twice of T is what? 2 times 15 over 4g. That would give you what? 15 over 2g. So 15 over 2g. So 15 over 2g is how much? 15 over 2 times 9.8. That would give you 73.5. Did they ask for the value or the force? Okay, the value of F. So the value of F is what? 73.5. That's it. We don't need units because they asked for the value. Fine. Okay. Next is part D. Part D, before part D, they are saying initially Q is 10 meter above the horizontal ground and P is more than 2 meter below the pulley. Q is 10 meter above the horizontal ground. You can see on the figure 3, and P is more than 2 meter below the pulley. Okay. At the instant when Q has descended a distance of 2 meter, after Q has descended 2 meter downward, the string breaks, the string has broken, and Q falls to the ground. Okay, the particle Q falls to the ground. Okay, so after descending for 2 meter, after descending for how much? 2 meter. So particle Q, the system has accelerated for what? This 2 meter distance, that 2 meter height. Okay, now part D is asking to find the speed of Q at the instant when it hits the ground. Okay, so after the string has broken, the particle Q will be freely falling under the force of gravity and it will hit the ground with a speed of v meter per second. Okay, we need to find out that speed v. Fine. Okay, so at first we need to find out the initial speed of particle Q. This is basically the speed when the string has been broken. Okay, so this speed is what? For this speed we need the acceleration of the system, right? So a equals to what? Acceleration of the system, uh, acceleration a is equals to how much? We know the equation earlier in part B. We got two equations, 5g minus t over 5. Okay, so 5g minus t, this is 15 over 2g over what? 15 over 2g. Okay, 5g minus 15 over 2g over 5. This is the what? Acceleration. Okay, so 5g minus 15 over 2g, 15 over 2 is 7.5. Right? It gives negative. Oh, the value of t is 15 over 4, not 2. Okay, okay, okay. This is 15 over 4g. Okay, so what would be the acceleration here? 5g minus 15 over 4g. So 5 minus 15 over 4, that would give you 5 over 4 over 5. This is basically what? 1 over 4g. Okay, this is 1 over 4g meter per second square. We got the acceleration. Now use this acceleration to find out the speed of Q when the string has been broken. Okay, so use this will be the initial speed, right? So we will use what? uh, the descended height is h is what? 2 meter, right? Acceleration is 1 over 4g meter per second square. And what else we know? The initial speed, the system was initially at rest, right? So this is the scenario. So we will use this formula, v square equals to u square plus twice of as. From there we need to find out the final velocity, right? So v equals to square root of twice of acceleration is 1 over 4g times 2. So this is basically the speed is what? Square root of g meter per second. So we got the speed of the particle q when the string is getting broken. Okay, so after the string has broken, this v will be now the initial, because with that speed it will start to move freely under the force of gravity. Okay, u equals to what? Square root of g meter per second. Fine. Okay, now we need to find out the v. The v is basically the speed when it is hitting the ground finally. Okay, so for finding v, what are the values we know? Height travel, this is 8 meter, because initially particle q was at 10-meter height, then it descended for 2 meter, then string has broken, and then remaining distance is how much? 10 minus 2, this is 8 meter. Acceleration is equals to g meter per second square, the gravity, the force of gravity. So v square equals to what? U square plus twice of as. So we need to find out v. So v equals to what? Square root of u square. U square is g plus twice of 8 times g. So how much is this? Square root of 17g. 17g meter per second. So this speed is basically square root of 17 times 9.8. That would give you 12.9 meter per second. This is the speed when the particle q is hitting the ground. Okay, and that's what exactly part D of question number 5 has asked for. That's it, and that's the end of question number 5 from Mechanics 1 October 2024 paper. That's it.